selecting the 7 characters and 14 contrasting traits, Mendel started his experiment. For the experiment, he selected only one character first. Then, for first experiment, he selected the height of plant. And thus, he selected a pure breeding tall plant and a pure breeding dwarf. Then these pure breeding tall and dwarf are cross-pollinated and produce the next generation. In the next generation, he got only tall plants. The parents were tall and dwarf, but all the offsprings in the first generation are tall. There is no anyone with a dwarf or with an intermediate height. This is the result of his first experiment. The crossbreeding is done by cutting and removing the anthers from one flower, and the anthers is collected from another dwarf plant and it is placed in the flower of the tall plant, or in the stigma of the flower present on the tall plant, and he got all the tall. This was his result. ഏഴ് ക്യാരക്ടറും സെലക്ട് ചെയ്തതിന് ശേഷം മെൻഡൽ പരീക്ഷണം തുടങ്ങുകയാണ്. ആദ്യത്തെ പരീക്ഷണത്തിൽ ഒരു ക്യാരക്ടർ മാത്രമാണ് കൺസിഡർ ചെയ്തത്. ഫസ്റ്റ് എക്സ്പെരിമെന്റിന് വേണ്ടിയിട്ട് ഒരു ട്രൂ ബ്രീഡിംഗ് ടോൾ പ്ലാന്റ് അതുപോലെ ഒരു ട്രൂ ബ്രീഡിംഗ് ഡോർഫ് പ്ലാന്റ് സെലക്ട് ചെയ്തു. എന്നിട്ട് അവ പരസ്പരം പരാഗണം നടത്തിക്കൊണ്ട് ഒന്നാമത്തെ ജനറേഷൻ പ്രൊഡ്യൂസ് ചെയ്തു. ഈ ഒന്നാമത്തെ ജനറേഷന്റെ എല്ലാ പ്ലാന്റ്സും ടോളയും വേറെ ഡോർഫോ അതല്ലെങ്കിൽ രണ്ടിന്റെയും ഇടയിലുള്ള ഹൈറ്റുള്ള ഒരു പ്ലാന്റോ ഡെവലപ്പ് ചെയ്തു. ഇതിന് മെന്റലിന് മനസ്സിലാവുന്നത് രണ്ട് ക്യാരക്ടേഴ്സ് പരസ്പരം കൂടിച്ചേരുമ്പോൾ ഓഫ്സ്പ്രിങ്സിൽ ഒന്ന് മാത്രമേ ഡെവലപ്പ് ചെയ്യുള്ളൂ, മറ്റേത് ഡെവലപ്പ് ചെയ്യില്ല എന്ന് മനസ്സിലായി. രണ്ടാമത് മെന്റലിന് ഇതിന് മനസ്സിലാവുന്നത് ഈ ക്യാരക്ടേഴ്സ് പരസ്പരം മിക്സ് ചെയ്യില്ല എന്ന് മനസ്സിലായി. Only one character is appearing in the first generation, and there is no blending or mixing of characters during the reproduction. Then after that, Mendel self-coordinated this and produced the second generation. In the second generation, he got both tall and dwarf. രണ്ടാമതായിട്ട് മെന്റൽ എന്താ ചെയ്തത്? ഒന്നാമത്തെ ജനറേഷന്റെ പ്ലാന്റിനെ സെൽഫ് പോളിനേഷൻ നടത്തി. അങ്ങനെ പഴവിത്തുകൾ കിട്ടി. ആ പഴവിത്തുകൾ മുളപ്പിച്ച് വളർത്തിയപ്പോ ടോളും കിട്ടി, ഡോർഫും കിട്ടി. ഇതാണ് രണ്ടാമത്തെ ജനറേഷൻ. ഈ ജനറേഷൻസിനൊക്കെ ഓരോ പേരുണ്ട്. ദി ഫസ്റ്റ് ജനറേഷൻ obtained by cross-pollination is known as F1 generation, filial 1 or F1 generation or filial 1 progeny. By selfing of the F1, he produced the next generation, and that generation is called F2 generation. So F2 generation is the generation produced by selfing of F1 generation. Thus, in the experiment, Mendel got the same character in the F1, but in the F2 he got both traits. Then, based on this result, he analyzed it, and based on mathematical logic, he introduced something. Firstly, the pole is obtained, character is obtained due to something passing from the parents into offspring. These physical structures passing from parents to offspring through gametes during fertilization or reproduction is called factors. That is the first term he introduced from his experiment. Now we are using genes for this, but Mendel got the 8 factors. So factors are present in the parents, and that factors are passing into the offspring through gametes during reproduction, and these factors are responsible for the development of characters. Now we are using genes instead of factors. Thus, for controlling the height, there are genes or factors. In the height, there are 2 traits, tall and dwarf. Thus, for controlling these traits, tall and dwarf, there are different factors or different genes. This pair of genes controlling different traits are known as alleles. So alleles are actually the genes with slight differences. Thus, from this first hybridization, the terms factors or genes and alleles are introduced. Genes are actually units of inheritance or heredity. They are the units of heredity. And for controlling 2 traits, there are 2 genes, or genes are occurring in pairs. If that pairs are slightly different, they are called alleles. Thus, he introduced certain symbols for representing the factors. He introduced the capital letter of the character which is appearing in the F1 for denoting the factor. Thus, for representing the tall trait, he used the symbol capital T. So, the factors or genes representing the tallness is capital T. They are occurring in pairs, so tallness is represented by capital T, capital T. Then the dwarf character is controlled by the factors or genes or alleles which are represented by small t and occurring in pairs or small t, small t. Thus, the character which is not appearing in F1 is represented by the small letter of the character which is appearing in F1, not small d or capital T, but small t, which is the small letter of the character which is appearing in the F1. The trait or character appearing in the F1 is known as dominant character. It is called dominant character. And the character which is not appearing in the F1 but appears in the F2. Here the example is a dwarfness, and this character is called recessive character. Recessive character. Thus, among the traits, there are dominant trait and recessive trait. The trait or character appearing in the F1 is called dominant character, and the character which is not appearing in the F1 but appears in the F2 are called recessive character. From Mendel experiment നടത്തി F1 ഉം F2 പ്രൊഡ്യൂസ് ചെയ്തു. എന്നിട്ട് ഇത് ഒന്നുകൂടെ സിമ്പിൾ ആക്കുന്നതിന് വേണ്ടിയിട്ട് ഇതിന് ജീനുകളെ റെപ്രസെന്റ് ചെയ്തു. ആ ജീനുകളെ റെപ്രസെന്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് ഉപയോഗിച്ച സിമ്പൽ എന്ന് പറയുന്നത് F1 ജനറേഷനിൽ അപ്പിയർ ചെയ്യുന്ന ക്യാരക്ടർ അല്ലെങ്കിൽ ട്രെയിറ്റിന്റെ ക്യാപിറ്റൽ ലെറ്റർ ആണ് അതിനു വേണ്ടിയിട്ട് ഉപയോഗിച്ചത്. അത് പെയറായിട്ടായിരിക്കും ഉണ്ടാവും. അതുകൊണ്ട് ടോൾ ഈസ് റെപ്രസെന്റഡ് ബൈ ക്യാപിറ്റൽ ടി, ക്യാപിറ്റൽ ടി. ആ ട്രെയിറ്റിന്റെ ഓപ്പോസിറ്റ് ഡോർഫിനെ റെപ്രസെന്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് ഡി എന്ന് ഉപയോഗിക്കുക. പകരം ആ ഡോമിനന്റ് ക്യാരക്ടറിന്റെ സ്മോൾ ലെറ്റേഴ്സ് ഉപയോഗിക്കുക. അതുകൊണ്ടാണ് ഡോർഫിൽ സ്മോൾ ടി ഉപയോഗിച്ചത്. Then in the F2 he got both tall and dwarf. Based on mathematical logic, this dwarfness is again appeared due to separation of these factors or genes during gamete formation or gametogenesis or during the meiosis. Thus, the gamete of the tallness possess capital for representing the gamete is encircled. So the gamete representing tallness is capital T. So what is the gamete of dwarfness? Yes, it is small t. Thus during fertilization, these two, capital T and small t, join to form the tallness or capital T, small t. Okay, you have to know very clearly this. This is the basic step in the law of inheritance. Then again, here tallness is represented by capital T, dwarfness by small t, small t. Here, the factors or genes present in an individual for the development of a character is known as genotype. Genotype or genotypic character. This is the genes present in an individual for representing a character or representing a trait. And due to the presence of this capital T, this plant is called, so that the expressed character, that is tallness, here the expressed character is dwarfness. Yes, this tallness, darkness, etc., which are expressed, and such expressed characters are called phenotype or phenotypic characters. Thus, the traits or characters can be divided into two. The characters which are appearing externally are called phenotypic characters, and the genes present in them for representing that character is called genotypic characters. So the phenotypic character of father, here we can say this is father and this is mother. The phenotypic character of the father is called as. What is the phenotypic character of the mother? Yes, it is darkness. Then what is the genotype of the father? Yes, the genotype of father is capital T, capital T. Then what is the genotype of dog? Yes, it is small t, small t. Thus, in the F1, all are told, although the genotype is different. Then, by selfing this, he produced the F2. F2 produced F1 plant in self-pollination. F2 produced. In the F2, he got both toad and dog. So, what is the genotype of the F1 plant? Genotype of F1 plant is capital T, small t. Then what are the gametes? The gamete of this plant is capital T. Then yes, small t. There are two types of gametes. One gamete containing capital T and the other gamete containing small t in the 50-50 ratio. 1:1 ratio. So this is the father, and the same way the mother, it also for selfing the same. So capital T, small t. Thus the F1 plant possesses two types of gametes, capital T, small t. Capital T, small t, these are the spurs or pollen grains, and this capital T, small t are the female gamete ova or ovules. Okay. Then by selfing of this, the F2 generation is formed, and during the F2 generation, with this gamete, the first is fertilized and produced capital T, capital T. What is the phenotype of this? What? Yes, this is tall plant. Then the same male gamete will fertilize into the second female gamete. And what is the phenotype? Capital T, small t. Capital T, small t. What is its phenotype? Look here. What is the phenotype? Yes, this is also tall. Then the second pollen grain will fertilize with the first ova and get capital T, small t. Capital T, small t. What is the phenotype? Again tall. Then the second pollen grain is fertilizing with the second ova, and what is the genotype? Small t, small t. When both are recessive, small t, small t. Then what is the phenotype? This is dwarf. So Mendel got this tall and dwarf in the F2, and he analyzed why the dwarfness is appeared in the F2. And based on mathematical logic, he observed that during the gametic formation, the two factors or two genes or two alleles present in an individual will separate, and allele is present in one gamete, then only the dwarf is appearing in the F. Now look, here pole is represented by capital T, capital T. In the F1, this is also told, but the genotype is capital T, small. So same phenotype told possess two different types of genotype. Here also, the first one is capital T, but the second and third, they are also told, but their genotype is capital T, small. From this, again, there are two terms. One is homozygous. Homozygous. If both alleles are same, that plant is called homozygous plant or homozygous individual. If the two alleles are different, like capital T, small t, here also capital T, small t, then it is termed as heterozygous. Heterozygous. Thus, what is meant by pure breeding or true breeding? We noticed that this is true breeding. This is also true breeding. That true breeding plant is either homozygous or heterozygous. Yes, it is homozygous. So pure breeding means they are homozygous, that means both the alleles are same type. But in heterozygous, the two alleles are different. So these are the terms you have to remember from this first cross. That is, the characters are controlled by the physical things known as factors. Later it is discovered as genes. Okay? Genes are the basic units of inheritance, or they are the units of characters. These genes or factors are occurring in pairs. For representing a character, there are two genes, and that genes are called alleles. So the pair of genes are also called alleles. Actually, alleles are the genes representing the different trait, that is pole and dwarf. ഒരു ക്യാരക്ടറിലെ രണ്ട് വ്യത്യസ്തമായ ട്രേറ്റുകളെ സൂചിപ്പിക്കുന്ന ജീനുകളുടെ പേരുകൾക്ക് alleles എന്ന് പറയും. So here the alleles in the pollus is capital T, capital T. The alleles in the dwarf plant dwarfness is small t, small t. The alleles for representing the pole in the F1 is capital T, small t. So these are the alleles. Then among these two traits, only one is appearing in the F1, other is masked. That appeared one is called dominant character. ഈ ക്രോസിംഗ് നടത്തി F1 ഒരു ക്യാരക്ടർ ഒരു ട്രെയിറ്റ് പ്രകടമാവുന്നുള്ളൂ, രണ്ടും കൂടെ വരുന്നില്ല. ആ പ്രകടമാവുന്ന ക്യാരക്ടറിന് അല്ലെങ്കിൽ ട്രെയിറ്റിന് ഡോമിനന്റ് ട്രെയിറ്റ് എന്ന് പറയും. ഒരെണ്ണം അവിടെ വന്നില്ല, അത് മറന്നുപോയി, പക്ഷെ അത് F2 വന്നു. അങ്ങനെ F1 വരാതെ F2 വരുന്ന ട്രെയിറ്റിനാണ് റെസസീവ് എന്ന് പറയുന്നത്. The trait which is masked in the F1 but appeared in the F2 are called recessive. Then characters നമുക്ക് രണ്ടായി മാറ്റാം. പ്രകടമായി പുറത്തേക്ക് കാണാൻ പറ്റുന്ന ക്യാരക്ടേഴ്സ് ഫീനോട്ടിപ്പിക് ക്യാരക്ടർ എന്ന് പറയും. ആ ക്യാരക്ടർ നമ്മുടെ ബോഡിയിൽ ഡെവലപ്പ് ചെയ്യണമെങ്കിൽ നമ്മുടെ കോശങ്ങളിൽ ന്യൂക്ലിയസിൽ അതിനെ കൺട്രോൾ ചെയ്യുന്ന ജീനുകൾ വേണം. ആ ജീനുകൾക്ക് ആ ക്യാരക്ടറിന് ജീനോടൈപ്പ് എന്ന് പറയുന്നത്. ഇപ്പൊ ഇവിടെ F1 അപ്പിയർ ചെയ്ത ക്യാരക്ടറാണ് ടോൾ എന്ന് പറയുന്നത്. ഹൈറ്റ് കൂടിയതാണ്, അതിന് ആ ടോളിന് ഫീനോട്ടിപ്പിക് ക്യാരക്ടർ എന്ന് പറയും. അതിന് കാരണം എന്താ? അതിന്റെ ഉള്ളിൽ ഈ രണ്ട് അലീൽസ് അല്ലെങ്കിൽ ജീനുകളുണ്ട്. അതുകൊണ്ട് ഈ ജീനുകൾക്ക് ജീനോടൈപ്പ് എന്ന് പറയും. ഓക്കെ, ഈ രണ്ട് ജീനുകളും ഒന്നാണെങ്കിൽ if both the alleles are same then they are called homozygous. If they are different then it is called heterozygous. ഇപ്പൊ ഇതില് homozygous ഉം heterozygous ഉം എക്സാമ്പിൾ കാണിച്ചത്. What are the examples for homozygous and heterozygous? Yes, this is homozygous and this homozygous, this heterozygous. So pure breeding means homozygous. Okay, yes. Then in the first experiment Mendel used only one character. He used only one character and he produced a plant with one character. An individual developed through crossbreeding is called hybrid. In this hybrid only one character is represented, so it is called monohybrid. Thus the F1 produced by two different traits through cross-pollination is called monohybrid, and monohybrid or hybrids are homozygous or heterozygous? They are heterozygous. Then a cross-pollination, a cross-hybridization considering only one character to develop a monohybrid is known as monohybrid cross. So the first experiment done by Mendel is monohybrid cross, or it is the inheritance of one gene. ഒരു ജീന് മാത്രമാണ്, ഒരു പെയർ ജീന് മാത്രമാണ് ഇവിടെ നമ്മൾ റെപ്രസെന്റ് ചെയ്തത്. അങ്ങനെ ഒരു ക്യാരക്ടർ മാത്രം കൺസിഡർ ചെയ്തുകൊണ്ട് ഉള്ള എക്സ്പെരിമെന്റിനാണ് മോണോഹൈബ്രിഡ് ക്രോസ് എന്ന് പറയുന്നത്. അപ്പൊ മെന്റൽ ആദ്യം ചെയ്ത എക്സ്പെരിമെന്റ് ഏതാ? മോണോഹൈബ്രിഡ് ക്രോസ്. ആ മോണോഹൈബ്രിഡ് ക്രോസിൽ നിന്നാണ് ഇത്രയും ടേമുകൾ ഡെവലപ്പ് ചെയ്തത്. ഓക്കെ, ഇനി ഇവിടെ look into the F2 generation. In the F2 generation there are tall and dwarf. How many tall are there? Yes, 3. And how many dwarf? 1. Thus in the F2 tall and dwarf are representing in the ratio 3:1. This is called monohybrid phenotypic ratio. What is this? Monohybrid phenotypic ratio. Then what is the monohybrid phenotypic ratio? This is 3:1. This is the ratio of two traits in the F2. 3 tall and 1 dark. 75% are tall, only 25% are dark. This is the phenotypic monohybrid ratio. Then what is the genotypic monohybrid ratio or monohybrid genotypic ratio? Look here. Yes, this is 1:2:1. What is 1? Yes, capital T, capital T. Then what is 2? 2, capital T, small t. Capital T, small t. Then what is this one? This is the small t, small t. So these are the explanation from the first experiment, that is monohybrid cross. Thus from this monohybrid cross, he introduced two basic principles of inheritance. When we are summarizing the information from this, we can see the characters are controlled by factors or genes. Characters are controlled by some physical things present in their body, and they are called factors, now genes. And they are occurring in pairs. That is the second point. They are occurring in pairs. If or that pair may be same or different, and so that pairs are also called alleles. When two different alleles are coming together, here capital T, small t came together, but the character of one is expressed. Thus, when two different alleles are coming together, only one is expressed and other is masked. That expressed character is called dominant character, and that masked one is called recessive character. Then this recessive character is appeared in the F2. Why it is appeared in the F2? Based on mathematical logic, it is due to separation of these two genes during gamete formation. If both these two are coming together in the gamete, there is no appearance of the dot. Thus, the fourth point from this monohybrid cross is during gamete formation, the allelic pair or gene pair representing a character will separate, and each gamete get only one allele. Based on these 4 points, two basic principles of inheritance or two basic principles of genetics is developed, and they are the law of dominance or first law, and second, the law of segregation or second law. The first law is called law of dominance. Law of dominance. This law of dominance has 3 points. 1, all characters are controlled by factors like The second point is that factors are occurring in pairs. Factors representing characters are occurring in pairs. And third point, when two different alleles or genes or factors are coming together, one is appearing and the other is masked. That is the third point. Based on that, this law is called the law of dominance. When two different alleles are coming together, one is expressed and the other is masked. The expressed character is called dominant character and the masked character is called recessive character. So this is the first law of inheritance or law of dominance, and it states that characters are controlled by factors or genes which are occurring in pairs. When two different genes or alleles are coming together, one is expressed and it is called dominant character, and the other is masked and it is called recessive character. Then the second law is called law of segregation. What is second law? Law of segregation. What is segregation? Yes, segregate means separate. എന്താണ് സെപ്പറേറ്റ് ചെയ്തത്? എന്താ സെപ്പറേറ്റ് ചെയ്തത്? ഗാമീറ്റ് ഫോം ചെയ്തപ്പോൾ ജീനുകൾ സെപ്പറേറ്റ് ആയി. അതിനാണ് ലോ ഓഫ് സെഗ്രിഗേഷൻ എന്ന് പറയുന്നത്. ഡ്യൂറിംഗ് ഗാമീറ്റ് ഫോർമേഷൻ ഓർ meiosis, the two genes representing a character will separate and each gamete receives only one gene or one allele, and this is called law of segregation. During gamete formation, the genes will separate and each gamete receive only one gene. So this is the monohybrid cross or inheritance of one gene and the two principles of inheritance, that is law of dominance and law of segregation. Is it clear? Okay? Yes. Then for representing the different genotypes during the cross-pollination, there is a graphical representation. Graphically, we can represent the different types of genotypes developed during the F1, F2, F3, etc. And this is called Hmyhss fire. So Hmyhss fire are certain squares for representing the probable genotypes developed or during a cross. This Hmyhss square is developed by the geneticist Reginald C. Hmyhss. It is introduced by Reginald C. Hmyhss, and so it is called Hmyhss square. In the Hmyhss square, we can easily represent all the probable genotypes. Then, for example, in the monohybrid cross between the tall and dwarf, in Thus, for representing this, the four genotypes are developed due to two gametes. The gametes are one capital T, then second small t. These are the pollen grains. Then again the ovum, capital T and small t. Then for representing this, we can draw four Punnett squares. In the top, we can represent the gametes, and in the left column again we can represent the end. Thus, easily we can represent the genotypes in the squares. Here capital T, capital T. So here, yes, capital T, small t. Here capital T, small t, and the fourth small t, small t. So very easily we can represent all the probable genotypes in these squares. This is introduced by Reginald Punnett and it is called Punnett square. And so Punnett square is the graphical representation of probability of the different genotypes during a cross. So this is about the first experiment conducted by Mendel. Then Mendel repeated the experiment by all other 6 characters. The position of flower, color of flower, shape of pod, shape of seed, color of pod, color of seed, etc. In all experiment he got the same result. There is no any difference. And so from this he introduced the 2 basic principles, and you have to know this. Thus, in the inheritance of first thing you have to remember some terms like factors or genes or alleles, then recessive character, dominant character, heterozygous, homozygous, phenotype, genotype, monohybrid cross, monohybrid, then the monohybrid phenotypic ratio and monohybrid genotypic ratio, and the Punnett square. Okay, thank you.